Howdy, everybody. Hope you're doing well wherever, whenever you are. Um, we're here doing more Advent to Code, trying to just solve some problems, see if we can't uh, improve our mental problem solving skills. My stutter suggests that maybe I need some more help in that department. But anyway, we're here solving day 9 of Advent to Code 2015. Again, I love all of your inputs. It's fun to collaborate. So just to see what your differences are and kind of compare and contrast, make me think. So with that being said, let's just move on to day 9. All in a single night. Every year, Santa manages to deliver all of his presents in a single night. This year, however, he has some new locations to visit. His elves have provided him the distances between every pair of locations. He can start and end at any 2 different locations he wants, but he must visit each location exactly once. What is the shortest distance he can travel to achieve this? Okay, so it's the traveling salesman problem, except you don't return to the beginning and you don't have a start and end. Or like you pick each of them. Okay, let's just finish reading. But this seems like we know what we need to do here in a second. For example, given the following distances: London to Dublin, London to Belfast, Dublin to Belfast, the possible routes are therefore these, and the shortest is this one. What is the distance of the shortest route? His elves have provided him the distances between every pair of locations. He can start and end in any 2 different. Yeah, so this is, again, this is similar to the traveling salesman problem. It solves the same way, I guess is the way to say it. It's just the difference between where do you start and end, and so we had to try them all. So this is an interesting problem because we know that it's an NP hard problem. So if you're not familiar with, computer science stuff, that's essentially just saying we know that this problem can't be solved in a super efficient way. There's no, like, how do I say this? There's no real great way to solve this other than just doing the brute force of trying all the possibilities. Having said that, though, I do remember, maybe someone can point me to I won't try and find it now, but I believe there's a paper sometime in the 80s or 90s that showed that, I actually don't remember when it was now, so don't quote me on that either, but there's a paper that showed that you could solve it in non-factorial time. So right now, the way I'm going to solve it is basically like n factorial, the number of cities. I'm just going to try all permutations basically and say what is the shortest of all the permutations. I think someone showed that you could do it slightly faster than that. It was something like n squared times 2 to the n. It was order n squared times 2 to the n or something like that versus n factorial. And I think the way they did that was with some caching efficiencies. And heuristics. I think they did it with like some heuristics. So, anyway, the point is even that number is still very large. There's just the way to think about it is there's no easy way to solve this except for just essentially brute forcing it. And you might try to optimize the brute force approach, but the algorithm itself is still essentially brute forcing it. And why is that important? Because when you find problems like this, you know that the best minds in the world, which is not mine, have come and said, this is the best we can do. And I don't know, maybe you're one of the great minds, and so you're trying to discover a better way to do it. That would be great. But as far as we know, there's not a better way to do this. And so you can find these problems whether you're at work or you're trying to solve an advent to code problem and say, oh, there's just no better way to do this. And I presume, like, you can see here they only have 3 cities that you're checking, and those 3 cities, it's because you literally have to check every single distance to find the shortest one. And so it's 3 factorial is the way to think about it. 3 times 2 times 1, which is 6. So you can see they have like 6 different ways to resolve how to do it, and they find like this one's the shortest, right? Well, that 3 is not big, but 20 factorial is huge. It's enormous, right? I don't know. There you go. 2.4 times e to the 18. So what is that in hundreds, thousands, millions, billions, trillions, quadrillions? It's in the quadrillions, right? Somewhere in the quadrillions. It's just an absurdly huge number, right? So we know that, like, the input is not going to... Ooh, I should probably... Why am I getting all that stuff? Zoop. Okay, so we know this is not going to be a huge puzzle input, which I think I saw, right? Like, these are just not... Well, I did see the puzzle input, but I didn't see how many there were. Yeah, there's only 28. 1, 2, 3, 4, 5, 6. I guess here's my brain working. I could have just looked over here. There's 7. So I presume there's only 7 cities in total, right? There's 7... and then 6. Oh, because you only have to list... We already know Tristram to Alpha Centauri, so we don't have to put Alpha Centauri to Tristram here. And then 5, 4, 3, 2, 1. Yeah. Okay, so there's only 7 cities, which is probably not a big problem. So we just want to do a permutation of 7. Which is probably not as big. I'm not... Yeah, 5,040. Okay, so that's not bad, right? So I'm basically, what I'm going to do is create 5,040 permutations, check the distances, and then see which one is and then keep the smallest. So that doesn't actually feel too hard, right? Again, 7 is a relatively small one, but it grows fast, right? Okay, so let's just start doing this. I'm inclined... Well, let's just start doing it. So we'll let lines equal... Actually, what do I want to get out of this? I want to get a distances. So we'll say let distances equal to input.lines.map. And I'm going to collect... It's going to be like a hash map, and I'm probably going to have both of the distances as the... or both of the strings is the key, and then the distance is the value. Right? Oh, does it not? Okay. So in here, I just do like let parts equal L dot split by white space collect. Well, I'm going to want to go from both ways, right? So Tristram to Alpha Centauri to Tristram. So I actually think I want a flat map and return both of them. Let dist equal parts. So I'm going to return parts 0, oops, parts 2. I need another one of these, and then dist. That. Okay, what doesn't it like? Type annotation needed. Vector. Closer. So, okay, so again, I'm doing a flat map, and basically the idea is I want to have both distances on either side, right? Like, what is the distance from here to here and there to back, there to the back? So Tristram to Farron is 108. Do I see a Farron to Tristan? Someone probably will see it before I do. Farron to Tammy, Farron. I'm sure it's in here. Oh no, did I miss it? Oh, here it is. Farron to Tristram, 108. 108. Yeah, okay. So that's what I'm expecting, right? So I have a map, and it's kind of duplicated in the sense that A and B are B and A. And so just to be clear, what's happening here is I'm going to return an array that's going to have, you know, the first one to the second one and the second one to the first one. But then I'm going to use flat map, which basically like takes the array, flattens it, and then we're going to put them all up into this hash map. So now we'll do like let cities equal distances dot into iter. No, distances dot keys dot map a hash set of stir. What doesn't it like about this? Oh, keys. Keys. I'm sure y'all yell at your screen, don't you? Oh, this is we need to dereference this. Okay, there's our all cities. Now we just need to permute through all of them. I actually have a permutation library. See, cd cargo add dingle bit combinatorics. So the way the combinatorics works is let's just look. We want to do permutations. And it is an iter. So we can go through all the permutations and just calculate their lengths. And we want to find the smallest one. So it will be like, we can actually do it in here, permutations. So we're going to, oh no, it's not 7. Oh, well, I know it's 7, but it would be cities.ling. So this is the specific permutation. And I mean, let's just return 1 right now, but we want to find the min of it. Like that. So what do I need to do in here? I want to find the distance from each city in the permutation list. So I could do a window with that. I could use a window to do that, right? I could say p dot windows to dot map LR to distances dot get okay or 0 dot sum. Is that right? Expected slice use. Oh, so I need to do like that. What doesn't like about this? Expected this. Oh, it's not. I mean, I'm definitely gonna have to do this, but these are just the pointers to the cities. Ooh, so I actually don't want this to be a hash set. That. And then it's going to be cities this, cities that. Okay, now what doesn't it like? A value of usize cannot be made result usize. What was that error? A value of usize cannot be made over an element of types result usize integer. Huh? Oh, this, wait, this should always, I think I can just do this and it's probably okay. Yeah. The okay or I think is the, maybe it's not okay or that this is always going to work. And that was my thinking, is like, it will just always work. So, okay. So we go through all the permutations. We go through all the windows of each permutation and calculate the distance and then sum up the distances. Then we find the distance. We unwrap it, return it. I mean, I think this should work. How long does it take? Oh, it actually, I was like, whoa, is that taking long? But I think it was just the build time. 251? Is that right? That seems low. Nope, got it. Okay. I mean, I guess I just didn't know. I didn't look at the numbers, but going over 7 cities. Oh, there are some low values. Okay. The example had somewhat higher numbers than mine, so that's probably it. Okay, so again, just to clear up what's going on here, this was one of those things where we like, oh, we know there's no efficient solution to this, so we're just gonna try them all. And that's where I use this permutation, right? So I say, go through all the permutations. For each permutation, go through each window of 2, meaning like check every 2. So it's going to slowly move through the array. We've used these before. And for each of those, I just get the distance from the first city to the second city and sum those up. And that gives me the total difference for that line. And then once I've done that, I can just return the minimum of them all. Okay. Part 2. The next year, just to show off, Santa decides to take the route with the longest distance instead. He can still start and end in any 2 different locations he wants, and he still must visit each location exactly once. For example, above, 982 is the largest. That one or that one. Oh, notably, those are the same because it's reversed, right? Oh, you actually see it in here. There's 2 605s and there's 2 659s because you're actually trying all of them. Okay, so we're just I mean, we can clean this up, but it's the same, right? We're just gonna go like this. But do that. How are you broken when I copy and paste, bro? Oh, I changed this. Okay. Okay. Okay, there you go. That's day 9. Again, so part 2, it just differs in that now you're finding the longest. So instead of doing the min, we do the max. So you could argue that I mean, I think this is fairly simple, but like this part could be duplicated, right? There's a lot of duplication here. There's even a lot of duplication here. Literally, the only difference is when you're doing min or max. I don't know how much effort we want to spend into optimizing or simplifying this, but it could be something along the lines of let's just do a parse function, which will give us a hash map of stir u size and a vec stir, and that would be these right here. Distances, city, like that. So now we could do let distances cities equals parse input, like that. Okay, just because we use them the same. Trying to think if there's some fun way to do this. This feels like readable enough that I feel okay showing this off and just saying, here's my solution. Where the only difference is min max. Like we could do something like I don't even know what the max. It is an iterator where, yeah, see, I don't know that there's not going to be an easy way to have like a higher order function where you say, hey, just call this thing on the items. So I'm inclined not to do that, right? Okay. Not too hard. This one's kind of funny because if you know the answer is I just have to solve them all. And let me just say, I could be wrong, but I think this is the case that the only known fastest solution to this is literally just n factorial, which is try all the solutions, with the caveat of I'm almost sure I've read an article that like simplifies that a little bit, but like not by much. It's still an NPR problem, I'm almost sure. Yeah, I'm sure I've done these before. Yeah, it is an NP hard problem. The difference is like in the Traveling Salesman, I think you have to like visit all of them and then come back to the beginning. Right? You imagine the case where that's where you live, and so you go to all of them and come back. In our case, we have to like try all of them because there is no end. There's a different beginning and end, but it's essentially the same problem, and it's known to be NP hard. And all that really means is like there's no efficient solution to it. So you're gonna have to try all of them again with the caveat of I'm pretty sure someone maybe can find this or point this out, but I think there's a white paper that shows that you can do it slightly faster, but it is that solution, if I remember right, was still NP hard. So anyway, I think that made it easier. I went off on a huge tangent. That definitely made it easier because I knew I only had to do this. But if you didn't actually know how to solve this initially, you may just say I'm going to try all of them myself, and that is the actual best way to do it in my mind. So again, if you have a better way, I'd love to see it. But it is kind of funny how like, have you ever seen those weird meme graphs where like, you know, the quote unquote like dumb side is, oh, just brute force it, and like the smart people trying to be smart are like, oh no, there's a better way, and then the smart people are like, just brute force it. This one turned out to like fit that graph, at least in my opinion. Because I think if you don't know that this is a traveling salesman problem and you try and optimize some kind of solution, it probably doesn't help you much, right? Like I solved 7 in 10 milliseconds. Anyway, there you go. There's day 9 in the bag. Again, I'd love to see your solutions, especially if you did something different or how you solved it differently would be great to see. And with that, we will talk to you next time. Bye, everybody.